All right, guys, we are moving into our atmosphere and oceans review. Today, we're going to look at wind currents and ocean current. So, we need to remember that the movement of air and water on Earth is fueled by convection currents. And convection currents are very important. We find them when we're talking about earth science. We find them in the atmosphere, we find them in the ocean, we find them in the lab. So remember that we represent convection currents with the arrow going up and the arrow going down. So the arrow going up represents warm fluid rising because it is less dense. And the arrow going down represents cool fluid, so that could be air or water, sinking because it is more dense. And we're going to look at some examples of this in the lab later. Now, the first thing we're going to talk about is currents in the air, so wind. And wind is created by the uneven heating of Earth's surface, okay? And all the heat on Earth's surface is coming from the sun, so that uneven heating is due to solar energy. And as you will remember, our little rhyme is that local winds blow from high to low. So wind blows from high to low, and we're talking about pressure there. So high pressure to low pressure. Now, global winds move from the warm equator, the warm air at the equator, towards the cool air at the poles, okay? And they move in these cells of these pockets of convection currents, okay? And those shift as the Earth rotates to where there are definite bands of these global winds. And they shift due to the Coriolis effect, okay? And remember that the Coriolis effect is due to the Earth spinning or rotating on its axis. And we'll talk more about the Coriolis effect when we get to our ocean currents as well. All right, so let's go ahead and look at ocean current. So there are two types of ocean currents that we talk about, or that we learned about. So the first one starts with solar energy from the sun, and that solar energy produces wind, okay, from the uneven heating of the Earth's surface, and then that wind blows across the ocean. And that creates surface ocean current. So surface ocean currents are the first type that we're going to discuss. And they are affected by three different things. The first thing is the global winds, which we just discussed. Second thing is continental deflection, which I'm going to show you an example of in just one moment. And the last thing is the Coriolis effect again. So they're going to shift according to whether they're in the northern hemisphere or the southern hemisphere. So here is an example from my kitchen of the continental deflection. So we have pepper, we have sand on the bottom, we have a continent made out of clay, and we have water. We're going to put the pepper on top of the water and it'll float. And then with my straw, I'm just going to blow a current of wind across the surface of the water. And please pay attention to the pepper, what happens with the pepper. You'll see that when it hits the continent, it deflects and it changes its initial path. So this is a great example of what happens as wind currents blow across the surface of the ocean. Okay, the second type of ocean current we're going to look at, so that was the first type, and the second type is going to be the deep currents. So deep currents are caused by differences in the density of water. So differences in water density. Okay. So the more dense water is going to sink, and the less dense water is going to rise. Now, there's specific characteristics of the more dense and the less dense water. The more dense water is going to be colder and also have a higher salinity, which is a higher salt content, where the less dense water is going to be warmer and have a lower salinity. Deep currents are often referred to as the Great Conveyor Belt. And that is because they are never ending. They are constantly moving the energy in the Earth's oceans all the way around the globe. So let's take a look at how salinity affects density. So we're going to put water, just tap water from the sink in 2 cups. And then I'm going to place an egg into 1 cup with just water, and it's going to sink down to the bottom. In the other cup, I'm going to add just regular table salt and pour it in and mix it up. When I put the egg into the salted cup, the egg is going to float. Now let's look at how temperature affects density of water. So I'm actually adding food coloring here to cold water. It's actually sitting on an ice pack, so you'll notice that the food coloring drops in and then tries to sink to the bottom, and it doesn't really mix around too well. So just observe that. And then now I'm going to add food coloring to hot water. So this is actually on the stove. And notice how the food coloring is going to rise up in a convection cell there. Next, I'm going to add the cold water and the warm water into a pan of just lukewarm water. You'll notice the cold water doesn't really do too much. You can kind of see it just kind of pool there at the bottom. Whereas when I add the hot water, you can see that it rises back up almost just as soon as I put it into the pan. So you could see the reaction on there, but I wanted to make it grander. So I'm gonna go ahead and just pour the hot water in and pour the cold water in. And you'll see how the cold water moves all the way across and stays at the bottom as it sinks, whereas the warm water rises to the top, and you can actually see 2 distinct levels there. The last thing we're going to talk about are just 2 key words that we keep referring back to throughout this unit, and that is upwelling, which is when the cold, deep water, that dense water, moves into coastlines, and as it moves in, it displaces the warm water and it creates a producer surge. Okay, so the producers love this cold, nutrient-rich water, and so they flourish. And when the producers flourish, that means that everybody else is happy, because the plankton, the phytoplankton, the algae, they all get eaten up by the primary consumers, and then it moves on up that food chain. And the last thing we're going to talk about is hurricanes. So hurricanes are fueled by warm equatorial ocean currents. And what happens is that warm water allows evaporation to occur. And as that warm air evaporates into the atmosphere, it starts circulating and these big storms are created.